Using a chemical equation to find moles of product from moles of reactant is kind of a precursor to the end game. Remember, we are eventually going to want to learn to convert grams of a reactant to grams of a product and vice versa. So this is getting us to concentrate on finding the mole ratio between product and reactant or vice versa from a balanced stoichiometric equation. And because Alex is going to give us a little workout today, Alex is also going to make us write our own equation from the description of a reaction. So we are given that ammonium perchlorate, NH4, that's the ammonium cation, right? NH4 plus perchlorate ion, ClO4 minus. Therefore, ammonium perchlorate will be this. It's a solid rocket fuel. It decomposes, so another example of a decomposition reaction into nitrogen gas, chlorine gas, oxygen gas, and water. Okay. Guess they're all gases because it's hot, right? It's a rocket fuel. Okay, so then it tells us how many moles of ammonium perchlorate we need to produce 0.065 of water. So we're trying to convert moles of product to moles of reactant. And once you sort of get in the zone on this and just use unit conversion to get from the thing that you've got to the thing you want, you're not going to really it won't matter to you if you're converting moles of reactant to moles of reactant, moles of product to moles of product, moles of reactant to moles of product, moles of product to moles of reactant, right? It doesn't matter because if you're using unit conversions and you get them the right way around, you can go whichever way you need to. But this is not balanced. So we're going to do a quick and dirty balance here. I can see I've got 1 nitrogen on the left side, 2 on the right. So I'm going to just do that as my first step. So let's do some accounting. We know we've got 2 nitrogens. We've got 8 hydrogens. We've got 2 chlorines. We've got 2 times 4 is 8 oxygens. So let's balance this all up. So the 2 nitrogens are correct over here. How many hydrogens we've got? We've only got 2 hydrogens, so we're going to have to fix that. We've got 2 chlorines, so that is safe. And then oxygens, we've got 2. So we can see what we have to do here. I'm going to deal with the H2O first because the oxygen's here and here. So I'm going to leave the oxygen till last. That's my strategy. So I want to end up with 8 hydrogens. So what I'm going to do is put a cheeky 4 in front of there. So now I've got 8 hydrogens. Okay, but that's also changed the number of oxygens. So now I've got 4, 5, 6 oxygens. Okay, not quite what I want to be, so I can put a cheeky 2 in there because I left that one to last. Now I've got 8 oxygens. All right, so balance. I'm going to get rid of that because it's taking up space. Boom, but there we are. So what we need to do is use the balanced chemical equation to write our mole ratio between the 2 things we're interested in, which is going to be water and the ammonium perchlorate. So 4 moles of water, 2 moles of ammonium chlorate. I strongly encourage you to write that mole ratio as an equivalency. So for every 2 moles of ammonium perchlorate that get burned, we are going to form 4 moles of water. Okay. So then all you need to do is use that equivalency as a unit conversion. So we have 0.065 moles of water to start with, and this is where whenever you're dealing with an equation and converting moles of one thing to moles of another thing, always say moles of what. Okay, so you might be used to be converting between mass and moles of a single species, right, for those little warm-up questions, but always say moles of what when you know you're going to have to use a mole ratio to convert between one thing and another thing. Okay, so then as far as my equivalency goes, my moles of water have to go on the bottom because that's what I want to cancel out. That's what I want to get rid of. So if you get confused about this kind of thing, just write the units before you even think about numbers. So I know I want to end up with moles of ammonium perchlorate on the top. So then I'm going to stick my 2 with that because it goes with it. And I'm going to stick my 4 with this because it goes with it. And then I have constructed my unit conversion that I'm going to be using. All right, so my moles of water should cancel out. So 0.065, where's my calculator gone, times 2 divided by 4 will give me my correct number of moles of ammonium perchlorate. I don't know if I can even read the screen on this, it's kind of dark. 0.065 times 2 divided by 4 is 0.0325. Alex asked us for 2 significant digits, so 0.33 moles. And because I've got my units there, I know the moles of what, right? Okay, so let's do another one just to make sure we got the idea here. Moles of oxygen to moles of water, sure, why not? Okay, so we're going to have to write a balanced equation first. Okay, so our reactants then are going to be liquid water and carbon dioxide gas. And we're going to form aqueous glucose, C6H12O6, and oxygen. So it's like the reverse of a combustion reaction, right? So to balance that, I'm going to do the same trick, balance carbon, then balance hydrogen, then balance oxygen. So 6 will balance the carbon. Hydrogen get balanced by another 6, and then oxygen, what have we got? Okay, so we've got 6 plus 12 is 18 oxygens. You've already got 6 there. 18 minus 6 is 12. So I'm going to make this 12. Boom. Okay, so that's how I'm going to balance that. All right, so moles of oxygen to moles of water. You can see it's a 1-to-1 ratio. Okay, but we're going to write it out anyway. For every 6 moles of water, we produce 6 moles of O2. So it's so important to follow through this process. Okay. To make sure that you are ending up with the right number of moles. Okay, even if it's 1-to-1, don't skip it, okay, because you might get an equation where it's not going to be 1-to-1, and then you're like, ooh, do I times by 2 or divide by 2 or blah, blah, blah. Like, just get in the habit of keeping those units in. So we start with 1.5 moles of water. We want to get rid of moles of water, so moles of water is going to go on the bottom. Okay, and then moles of oxygen is going to go on top. Okay, and we know from that equivalency we just wrote that 6 moles of oxygen are made from 6 moles of water. Okay, so it's the same as 1-to-1. 6 divided by 6 is 1. Okay, but just get in the habit of putting it in there. Honestly, it makes life so much easier. And you see that we have converted the units from water to oxygen. So in this case, it's going to be the same, 1.5 moles of oxygen. No calculator required. Okay.